Bye.
Okay, so good afternoon everyone. So in our previous lecture, we have seen the various psychometric relations. So under that various psychometric relations, we have seen the formulas for near about 6 psychometric terms. So out of that, so first of all, we have seen the formula for humidity or specific humidity or moisture content in terms of partial pressure of water vapor. So that formula is nothing but small w is equal to small w, that is nothing but humidity or specific humidity, and that is given by equation 0.622 PV divided by P minus PV, whereas PV is nothing but partial pressure of water vapor, and that PV is nothing but the saturation pressure corresponding to dew point temperature. P is nothing but barometric pressure, and again PV is nothing but partial pressure of water vapor. Then second formula we have seen related to degree of saturation or percentage humidity related to mu. So we are knowing that mu is given by equation. So this is the formula. Next formula, mu is given by equation PV by PS into 1 minus PS by P divided by 1 minus PV by P. So this is the another formula related to degree of saturation or percentage humidity. Here PV is nothing but partial pressure of water vapor of moisture. PS is nothing but partial pressure of water vapor in the saturated air. So here value of PV is calculated either by Carrier's equation, or that will be calculated by using the steam table. So in the steam table, if we will take the saturation pressure corresponding to dew point temperature, that is nothing but PV, and PS is nothing but saturation pressure corresponding to dry bulb temperature. So from steam table we can find out the value of PS also. The next formula we have seen related to relative humidity, that is nothing but phi. So we are knowing that relative humidity is given by equation. So this is the formula for relative humidity. So relative humidity is given by equation PV by PS, whereas PV is nothing but partial pressure of water vapor in the moist air. PS is nothing but partial pressure of water vapor in the saturated air. And after finding out the value of phi as a PV by PS, we can get the correlationship between mu and phi. Mu means degree of saturation or percentage humidity. Phi means relative humidity. So correlationship between mu and phi is nothing but mu is equal to phi into 1 minus inside the bracket PS by P divided by 1 minus PV by P. So this is related to mu. Then fourth formula we have seen related to the PV. So as I have told you, we can find out the value of PV by two ways. First way is by using the steam table. Second way is by using the Carrier's equation. So by using the Carrier's equation, we can find out the value of PV as a PW minus inside the bracket PV minus PW inside the another bracket TD minus TW divided by 1544 minus 1.44 TW. So here one thing you have to keep in mind, this formula is exactly like this. Like this. Okay. So that PW is separate term and remaining term is inside the bracket minus remaining term. So PV is nothing but partial pressure of water vapor in the moist air. PW is nothing but saturation pressure corresponding to wet bulb temperature that is obtained from the steam table. Then PB is nothing but barometric or atmospheric pressure. TD is indicating dry bulb temperature. TW is indicating wet bulb temperature. The fifth formula is related to vapor density. That is also called as the absolute humidity. So vapor density or absolute humidity is nothing but mass of water vapor present in 1 meter cube of dry air. Mass of vapor density means mass of water vapor present in a 1 meter cube of dry air, and that rho v Vapor density is denoted by term rho V, and that is given by equation small w. Small w means humidity or specific humidity. That value of humidity or specific humidity should be in terms of kg per kg of dry air. Pb minus Pv. Pb means barometric pressure. Pv means partial pressure of water vapor corresponding to moist air. And this both the terms should be in terms of bar. If both the terms will be in terms of bar, then I have to multiply it by 10 raised to 5 divided by Ra. Value of Ra I have to take as a 287 joule per kg Kelvin. And Td is nothing but dry bulb temperature in terms of Kelvin. This value should be in terms of Kelvin. That's why I have written as a Td. Otherwise, I might have written it as a small Td. So this small Td is indicating dry bulb temperature in degree centigrade. And here, likewise, capital Td is indicating dry bulb temperature in Kelvin. So this is the formula related to vapor pressure or absolute humidity. Then sixth one is related to enthalpy or total heat of moist air. So enthalpy or total heat of moist air is given by equation 1.022 Td. Here Td is nothing but dry bulb temperature. Here small Td is there. Indication of small Td is nothing but that dry bulb temperature should be in terms of degree centigrade. Small w plus small w. Small w means specific humidity in kg per kg of dry air. Inside the bracket hfg of dp. dp means dew point temperature. So whatever this value of hfg we have to find out from steam table, that should be corresponding to dew point temperature plus 2.3 tdp. So that value should be in terms of kilojoule. So these are the various formulas by using which we have to find out the various properties of the air. Now, why it is necessary to have, or why it is necessary to find out the various properties of the air? So suppose I want to do the air conditioning, or I want to install one air conditioning plant. And for installation of air conditioning plant, suppose this is my enclosed space. This is my enclosed space. So that may be mall or cinema theater or anything else where we require the air conditioning. So here my desirable atmospheric condition, suppose I want to obtain the temperature. I want to obtain the temperature inside the mall between 25 to 28 degrees centigrade. Suppose between 25 to 28 degrees centigrade. And here, suppose humidity, or suppose a relative humidity which I want to maintain here inside this mall, suppose 50 to 60%, in between 50 to 60%. So how I can achieve this desirable internal atmospheric condition? How I can achieve this desirable internal atmospheric condition? So for achieving this desirable internal atmospheric condition, I need to first of all calculate load inside this room or load inside that mall or cinema hall. So here I need to calculate the different parameters which are affecting on the, or which are releasing the heat or which are absorbing the heat. So depending upon that, I will calculate the load. And after calculation of load, so according to the internal desirable atmospheric condition, I need to do the processing on the external air. So whatever external atmospheric air will be there, so on that external atmospheric air, I need to do the various processing. Now suppose whatever may be the condition at the outside, that may be lower, or that temperature may be lower or higher, humidity may be lower or higher. So up to which point we need to do the processing. So for that purpose, we should know the various properties, or we should know the various psychometric terms of that moist air. That means I should know what is the dry bulb temperature of that moist air. I should know what is the wet bulb temperature of that moist air. Then I should know what is the dew point temperature of that moist air. What is the enthalpy of that moist air. Then what is the specific humidity ratio of that moist air. Then degree of saturation or percentage humidity of that moist air. Then relative humidity of that moist air. Then vapor pressure or vapor density of that moist air. So I need to know various properties of that external moist air. So by knowing this various property, I can do the processing accordingly, and after doing the processing accordingly, I can obtain the desirable atmospheric condition. So here, how to find out these various properties of moisture? So for that purpose, we have seen the various psychrometric relation. So with the help of this various psychrometric relation, if I am knowing the any 2 or 3 parameter related to the atmospheric air, if I am knowing the any 2 or 3 parameter related to the atmospheric air, then by using these psychrometric relations, I can find out all remaining parameter. I can find out all remaining parameter. How I can find out all remaining parameter? For that purpose, we will take one example as a numerical. So here we'll take one example. So on a particular day, the atmospheric air was found to have dry bulb temperature 30 degrees centigrade and wet bulb temperature 20 degrees centigrade. On a particular day, the atmospheric air was found to have dry bulb temperature 30 degrees centigrade, wet bulb temperature 20 degrees centigrade, and barometric pressure was observed to be 740 mm of Hg. 740 mm of Hg. That means whatever atmospheric pressure is there, atmospheric pressure is 740 mm of Hg. Using steam table, determine dew point temperature of that moisture, relative humidity of that moisture, then specific humidity of that moisture, then degree of saturation of that moisture, then vapor density of that moisture, and enthalpy of the mixture per kg of that dry air. So here, if you find out or if you read this problem carefully, you will come to know that here only they have mentioned only 3 property, or rather than 3, only 2 property related to the atmospheric air. So related to the atmospheric air, we are knowing only dry bulb temperature and wet bulb temperature, and also we are knowing the barometric pressure of that atmospheric air. So depending upon this given quantity, I have to find out what will be the dew point temperature of that air, what will be the relative humidity of that air, what will be the specific humidity of that air, then what will be the degree of saturation of that air, then what will be the vapor density of that air, and what will be the enthalpy of mixture per kg of the dry air. So to find out this 6 quantity based on 2 quantity only, to find out this 6 quantity based on only 2 quantity, I have to use the various psychrometric relations which we have seen yesterday. So by using these various psychrometric relations, I can find out all those values. Now, how can I use these psychrometric relations? For that purpose, first of all, I will write down the given data. So what is the given data? First of all, they have mentioned the dry bulb temperature. What is the dry bulb temperature of the air? 30 degrees centigrade. Wet bulb temperature of the air as a 20 degrees centigrade, and barometric pressure. So we are indicating barometric pressure by P or PB. So that barometric pressure is 740 mm of Hg. Barometric pressure is 740 mm of Hg. Now, here what I have to find out? I have to find out first of all dew point temperature of that air. So I should know the value of TDP, dew point temperature. Then I have to find out the second one as a relative humidity of that air. Then third one as a specific humidity of that air, I have to find out. Then fourth one, I have to find out the degree of saturation or percentage humidity. Fifth one, I have to find out the vapor density. And sixth one, I have to find out the enthalpy of the air. So first of all, we'll find out the dew point temperature. So here they have mentioned the dry bulb temperature, they have mentioned the wet bulb temperature, and they have asked us find out the dew point temperature. So how should I find out the value of dew point temperature? So before proceeding towards next point, you should always remember here 3 types of pressures are there. First one is called as a PV, second one is called as a PW, and third one is called as a PS. You should first of all clear this thing. So PV is nothing but partial pressure of water vapor in the moist air. PS is nothing but partial pressure of water vapor in the saturated air, and here PW is nothing but saturation pressure corresponding to wet bulb temperature. So here whatever these three values are there, PV, PS and PW, these are corresponding to three temperature. These are corresponding to three temperature. So whatever PV is there, that PV is corresponding to dew point temperature. PV is corresponding to dew point temperature. PW is corresponding to wet bulb temperature. PW is corresponding to wet bulb temperature, and PS is corresponding to dry bulb temperature. That means if you are having the steam table, and if you are knowing the value of PV, then corresponding temperature is called as a dew point temperature. Or if you are having dew point temperature, and by using the steam table, corresponding pressure will be called as a PV. If you are having the wet bulb temperature, corresponding value will be called as a PW. Or if you are knowing the value of PW, corresponding temperature from the steam table will be called as a TW. And PS, if you are knowing the dry bulb temperature, corresponding value of pressure will be called as a PS. Or if you are knowing the value of PS, corresponding value of temperature will be called as a dry bulb temperature. Okay, now here they have given the two values of temperature. First one is dry bulb temperature, second one is wet bulb temperature. So by using steam table, corresponding pressure will be called as dry bulb temperature corresponding pressure ला काय म्हणणार आहे आपण, the corresponding pressure, saturation pressure corresponding to dry bulb temperature will be called as a PS. या ठिकाणी PS ची व्हॅल्यू मिळेल स्टीम टेबलचा सहाय्याने. And here TW, so corresponding value of pressure will be called as a PW. That will be equal to PW. Now here dry bulb temperature 30 degree, wet bulb temperature 20 degree centigrade. So by using steam table, I will get the value of PS, I will get the value of PW. How I will get that value, I will tell you. Wait for 1 minute. I will open the steam table. Wait for 1 minute only. Okay. So here you are observing the steam table. So in steam table there are various values. So you have to always refer the steam table corresponding to saturated water and steam. Saturated water and steam. So here saturated water and steam. So temperature table. So here if you see, okay, here if you see in the first column they have mentioned the value of temperature, in the second column they have mentioned the value of pressure, in the third column they have mentioned the value of specific enthalpy, that will be in terms of kilojoule per kg. Fourth column specific entropy, kilojoule per kg Kelvin, and fifth one is specific volume in terms of meter cube per kg. Here units are also important. So here unit, whatever units are there, first one unit of temperature is in terms of degree centigrade, unit of pressure is in terms of bar, and whatever HF, HFG, HG enthalpy values are there, those are in terms of kilojoule per kg. Entropy values are in terms of kilojoule per kg Kelvin, and volume is in terms of meter cube per kg. Now from the problem, so they have mentioned the dry bulb temperature as a 30 degree centigrade and wet bulb temperature as a 20 degree centigrade. So corresponding pressure values, so 20 degree centigrade dry bulb temperature, corresponding pressure, पहिला कॉलम जो आहे तो ड्राय बल्ब टेम्परेचरचा आहे, फर्स्ट कॉलम जो आहे तो ड्राय बल्ब फर्स्ट कॉलम जो आहे तो टेम्परेचरचा आहे, सेकंड कॉलम जो आहे तो प्रेशरचा आहे. सो 20 डिग्री सेंटीग्रेडच्या करस्पॉन्डिंगचं प्रेशर आणि 30 डिग्री सेंटीग्रेडच्या करस्पॉन्डिंगचं प्रेशर वी हॅव टू फाइंड आउट. सो फॉर दॅट पर्पज For that purpose, here what I will do, so here as my dry bulb temperature is 30 degrees centigrade, as my dry bulb temperature is 30 degrees centigrade, so corresponding pressure is equal to 0.0425. So temperature corresponding to dry bulb temperature, pressure corresponding to dry bulb temperature will be called as a value of PS. So here I will automatically get the value of PS as a 0.0425 bar, and as wet bulb temperature is 30 degrees wet bulb temperature is 20 degrees centigrade, so here there is 20 degrees centigrade, so related to or corresponding to 20 degrees centigrade, whatever pressure is there, 0.0234 bar, that is the pressure saturation pressure corresponding to wet bulb temperature. So this is the value of PW, and whatever this value corresponding to 30 degrees centigrade value is there, this value, so this is value of PS. Are you getting? So here so here I will get the temperature, or I will get the value of TS corresponding to PD, and value of TW corresponding that pressure is nothing but PW. So to calculate the value of dew point temperature, I should know the value of PV. As both the values are not available, that means PV ची value नाही, त्यामुळे dew point temperature find out करू शकत नाही. So to calculate the value of PV, I am having the another equation, or I am having the another method. So by using the Carrier's law, I can find out the value of PV. But before proceeding that, here one more thing. If you see the steam table, in the steam table, whatever values of pressures are there, those values of pressures are in terms of those values of pressure are in terms of bar. But here whatever values of pressure they have given, that value is in terms of mm of Hg. So first of all, I need to convert that pressure from mm of Hg into bar. And for conversion of value of mm of Hg into bar, I should know 1 mm of Hg. 1 mm of Hg is equal to 133.3 mm of Hg. 1 mm of Hg is equal to 133.3 Newton per meter square. 133. All of you please write down this value. This is also important value, 133.3 Newton per meter square. Okay. And as in the steam table, we are having the values in terms of pressure, in terms of bar. That's why I need to convert that Newton per meter square into bar also. So we are knowing that 1 bar is equal to 10 raised to 5. 1 bar is equal to 10 raised to 5 Newton per meter square. 10 raised to 5 Newton per meter square. Okay. 1 bar is equal to 10 raised to 5 Newton per meter square. So I need to convert that pressure, barometric pressure, in terms of bar. So here, to calculate the value of dew point temperature, first of all I will use the equation of PV. So we are knowing the value of PV is equal to PW minus PV minus PW, TD minus TW divided by 1544 minus 1.44 TW. Out of that PW कुठून घेतला आपण, हे जे काय TW होतं, TW च्या करस्पॉन्डिंगचं प्रेशर, TW च्या करस्पॉन्डिंगचं प्रेशर फ्रॉम स्टीम टेबल म्हणजे काय झालं, PW झालं. PB म्हणजे काय, बारोमेट्रिक प्रेशर. हे बारोमेट्रिक प्रेशर आहे, पण ऍज इट इज घेणार का आपण, ऍज इट इज घेणार नाही. आय नीड टू कन्वर्ट दॅट barometric pressure in terms of bar. So for that purpose, what I am going to do, 740 into 133.3, that will be in terms of Newton per meter square. आणि ती जी काय व्हॅल्यू येणार आहे त्याला मी काय करणार आहे, 10 raised to minus 5 न मल्टिप्लाय करणार आहे, जेणेकरून that value will be in terms of bar आहे. Then PW ऑलरेडी आपण कॅल्क्युलेट किंवा फाइंड आउट केलेला आहे. TD, value of TD is known to me. It is the value of TD. This is the value of TD. Then TW value is also known to me, 1544 minus 1.44 TW. So all the values are known to me. So by putting all those values, I will get the value of PV. So here from steam table I have found out, or I have told you how to find out. So as wettable temperature is 20 degrees centigrade, so corresponding pressure is 0.02337. आपण जर बघितलं स्टीम टेबल वरती, ट्वेंटी बारच्या करस्पॉन्डिंगचं प्रेशर. सो 20 बारच्या करस्पॉन्डिंगचं प्रेशर किती आहे, 0.0234. आणि आपल्याकडे काय आलेलं आहे, 0.02337, म्हणजेच 0.0234 आहे, 37 आहे, 0.0234 bar. So this is the value of PW. Then I will convert that PB from mm of Hg into bar. So first of all, for conversion of mm of Hg into Newton per meter square, as I am knowing 1 mm of Hg is equal to 133.3 Newton per meter square. Is there. So multiply it by 133 into 740. So I will get that value is in terms of Newton per meter square. Again convert that Newton per meter square in terms of bar. So into 10 raised to minus 5. So I will get the value of barometric pressure as a 0.98642 bar. 98642 bar. So this will be the value of barometric pressure. After that, I will put that values, all those value in the equation of PV. So PV is equal to PW. So this is the value of PW minus, या ठिकाणी ब्रॅकेट मध्ये PB. This is the value of PB minus PW into another bracket TD minus TW divided by 1544 minus 1.44 TW. So finally I will get the value of pressure, value of PV as a 0.01701 bar. So this is the value of PV. पण मला ह्या ठिकाणी PV ची व्हॅल्यू कॅल्क्युलेट करायची आहे का? नो, आय हॅव टू फाइंड आउट द व्हॅल्यू ऑफ TDP, ड्यू पॉइंट टेम्परेचरची व्हॅल्यू फाइंड आउट करायची. तर PV वरून ड्यू पॉइंट टेम्परेचरची व्हॅल्यू कशी फाइंड आउट करणार? आतापर्यंत आपल्याला कसं बघितलं होतं, TW असेल तर त्या करस्पॉन्डिंगचं प्रेशर म्हणजे PW झालं, आणि PV असेल तर त्या करस्पॉन्डिंगचं टेम्परेचर म्हणजे काय झालं, ड्यू पॉइंट टेम्परेचर. आता आपल्याला काय मिळालेलं आहे, PV मिळालेलं आहे, त्याच्या करस्पॉन्डिंगचं टेम्परेचर मला फाइंड आउट करायचं आहे. सो अगेन आय एम गोइंग टू सी द स्टीम टेबल. सो फ्रॉम स्टीम टेबल आता माझ्याकडे कितीची व्हॅल्यू आली, PV ची व्हॅल्यू काय आली, 0.01701, 0.01701. तर आता मी काय करणार, सो स्टीम टेबल I am going to check the value of pressure as a 0.01701 bar in the pressure column. So 0.017 bar. So here 0.01701 किंवा 0.0170 बार. आता ह्याच्या करस्पॉन्डिंगचं टेम्परेचर किती आहे? ह्याच्या करस्पॉन्डिंगचं टेम्परेचर किती आहे? 15 डिग्री आहे. सो हिअर व्हॅल्यू ऑफ ड्यू पॉइंट टेम्परेचर इज इक्वल टू 15 डिग्री सेंटीग्रेड. Are you getting? From steam table, as I am getting the value of PV, so corresponding temperature will be the dew point temperature. So here, as I am getting the value of PV as a 0.01701 bar, so corresponding temperature is nothing but dew point temperature, and that value is 15 bar. So from steam table, we'll find out the corresponding temperature or temperature corresponding to pressure 0.01701 bar. So I will get the value of dew point temperature. Are you getting? Are you getting the problem? Write in the chat box, yes or no, so that we can proceed further. Or if you are facing any problem or any query, you can ask me. Are you getting the problem? What about remaining student? What about remaining student? Okay. So after finding out the dew point temperature, now we'll find out the second point, that is nothing but a relative humidity. So after finding out dew point temperature, we'll find out second point, that is nothing but a relative humidity. So we are knowing the formula for relative humidity. Relative humidity is given by equation PV by PS. त्यापैकी PV ची व्हॅल्यू आपल्याला माहित आहे किती, 0.01701 बार, आणि PS म्हणजे काय, आपल्याला ड्रायबल टेम्परेचर दिलेलं आहे 30 डिग्री सेंटीग्रेड. त्या ड्रायबल टेम्परेचरच्या करस्पॉन्डिंगचं प्रेशर स्टीम टेबलवरून, दॅट इज नथिंग बट व्हॅल्यू ऑफ PS. So here from steam table we'll find out the value of PS. That value of PS is nothing but pressure corresponding to 30 degree centigrade. So if I will see the steam table, steam table, so corresponding to 30 degree centigrade, whatever pressure is there, that is nothing but 0.0425 bar. So here 0.0425 bar. So here we are getting the same. So PS, so directly I can find out from the steam table 0.0425 bar or 0.0424 bar. So this is the value of PS. As I am getting the value of PS as well as PV, so I will put the value of PV and PS. So this is the value of PV, this is the value of PS. I will get the relative humidity, and as always relative humidity is in terms of percentage. That's why relative humidity is equal to 0.40 म्हणजे किती झालं, 40% झालं. 0.40 म्हणजे 40%. So this is the another value. Then third value we'll find out related to the specific humidity. So specific humidity, as we are knowing the formula for specific humidity is given by equation 0.622 PV divided by PB minus PV. Out of that I am knowing the value of PV, I am knowing the value of PB, I am knowing the value of PV. Put all those values, 0.622 into PV, PV म्हणजे 0.01701, PB 0.98642, PV 0.01701. So by putting all those values, I will get the value of small w in terms of kg per kg of dry air. This is the value. By using this formula, whatever value of small w I will get, that is in terms of kg per kg of dry air. If I want to convert that in terms of gram per kg of dry air, so multiply it by 1000. So I will get that 10.914 gram per kg of dry air. Okay, but afterwards whatever values, or always whatever value of small w we are requiring, that should be in terms of kg per kg of dry air. So this is the third value. Then after that I have to find out the value of degree of saturation. That is nothing but I have to find out the value of mu. So as we are knowing the value of mu is nothing but upon ws. but W upon WS. That means specific humidity of moist air divided by specific humidity of saturated air. Out of that, value of W we have calculated. Specific humidity of moist air we have calculated by using this formula. Specific humidity of moist air we have calculated by using this formula. So here, if I will use the formula of WS, so what is the formula of WS? That also we have seen. Instead of PV, that will become as a PS only. So this is the formula of WS. So here, by using this formula, I will calculate the value of WS, and after calculating the value of WS, I will put that value of W. This is the value of W, and from this equation, whatever value I am getting, that is I will automatically get the value of mu. So first of all, I will calculate the value of WS. WS is nothing but 0.622 PS divided by PB minus PS. Effective PS we have already calculated. PS ची value आपल्याला माहित आहे. PB already we have calculated. PS already we are made. So after putting those values, so 0.622, this is the value of PS, PB minus PS. So I will get the value of WS. So after getting the value of WS, and as I am knowing the value of small w also, specific humidity of moist air, so put those values in the equation of W upon WS. So as mu is equal to W upon WS, put the value of W and WS, I will get the value of mu. So that percentage humidity or degree of saturation will be always in terms of percentage. So mu is equal to 39.1%. Mu is equal to किती आलं होतं 0.391 आलं होतं 0.391 म्हणजेच किती झालं 39.1% झालं. Are you getting? Yes or no? So this is the value of mu. After getting the value of mu, again we have to find out the value of rho v. After getting the value of mu, now I have to find out the value of rho v. So to calculate the value of rho v, we are knowing the formula. To calculate the value of rho v, we are knowing the formula. Rho v is given by equation W, that is specific humidity. That should be in terms of kg per kg of dry air. This value should be in terms of kg per kg of dry air. PB minus PV. आता हे PB आणि PV च्या ज्या व्हॅल्यू घेतलेत आपण त्या कशामध्ये घेतलेत बार मध्ये घेतलेले आहेत. That value we have taken in terms of bar. That's why into 10⁵ should be there to convert that bar into Newton per meter square divided by RA. RA किती घ्यायचा आहे आपल्याला 287 घ्यायचा आहे. आणि TD म्हणजे काय ट्रायबल टेम्परेचर इन केल्विन आहे कॅपिटल T आहे. सो 273 प्लस ट्रायबल टेम्परेचर किती 30 आहे. So this conversion factor is very much important. If you take the value of TD in terms of degree centigrade, your answer will be wrong. By mistake, if you take the value of RA as a 0.287, your answer will be wrong. By mistake, if you take the value of PB and PV in terms of bar, again your answer will be wrong. By mistake, if you take the value of small w in terms of gram per kg of dry air, again your answer will be wrong. So this is very much important formula, and unit conversion is most important. Okay, so here, as all the values are known to me, W ची व्हॅल्यू ऑलरेडी कॅल्क्युलेट केलेली आहे, PB ची व्हॅल्यू माहित आहे, PV ची व्हॅल्यू माहित आहे, RA 287 घ्यायचा आहे, ड्रायबल टेम्परेचर 30 डिग्री सेंटीग्रेड आहे पण केल्विन मध्ये घ्यायचा म्हणून 273 न ऍड करणार आहे. सो हियर आय विल गेट द व्हॅल्यू ऑफ रो v that should be in terms of kg per meter cube. Value of rho v that is in kg per meter cube. Are you getting? And lastly, I have to find out the value of HFG. I have to find out the value of enthalpy. So enthalpy of moist air is calculated by using the formula H is equal to 1.022 TD. TD म्हणजे काय ट्रायबल टेम्परेचर कशामध्ये डिग्री सेंटीग्रेड किती आहे 30. स्मॉल w कशामध्ये घ्यायचं आहे kg per kg ऑफ ड्राय एअर मध्ये ही व्हॅल्यू आपल्याला माहित आहे. HFG ऑफ DP प्लस 2.3 TDP. आता TDP ड्यू पॉइंट टेम्परेचरची व्हॅल्यू माहित आहे आपल्याला किती आहे. ड्यू पॉइंट टेम्परेचर किती आलेलं आहे 15 डिग्री सेंटीग्रेड आलेलं आहे. ड्यू पॉइंट टेम्परेचर किती आलेलं आहे 15 डिग्री सेंटीग्रेड आलेलं आहे. सो हिअर ॲज अ TDP आय विल पुट ॲज अ 15 डिग्री सेंटीग्रेड स्मॉल TA म्हणजे डिग्री सेंटीग्रेड मध्ये. फक्त ह्या ठिकाणी इम्पॉर्टंट पॅरामीटर कोणता आहे HFG ऑफ DP म्हणजे आय हॅव टू फाइंड आउट लॅटेंट हीट ऑफ वेपरायझेशन corresponding to dew point temperature, and that I have to calculate from, or that I have to find out from steam table. Dew point temperature किती 15 डिग्री सेंटीग्रेड आहे, तर 15 डिग्री सेंटीग्रेडच्या करस्पॉन्डिंगचं TDP ची व्हॅल्यू कॅल्क्युलेट करायची. आता ह्या ठिकाणी जर बघितलं आपण स्टीम टेबल मध्ये HFG म्हणजे ही व्हॅल्यू फाइंड आउट करायची मला. दिस इज द व्हॅल्यू ऑफ HFG. किती डिग्री सेंटीग्रेडच्या करस्पॉन्डिंगची फाइंड आउट करायचे 15 डिग्री सेंटीग्रेडच्या करस्पॉन्डिंगची. So this is the 15 degree centigrade. This is the 15 degree centigrade, and corresponding to that 15 degree centigrade, I have to find out the value of HFG. So here, this is the value of HFG. So that value of HFG. What is the value of HFG? So HFG of DP. HFG of DP म्हणजे काय? ड्यू पॉइंट टेम्परेचर 15 डिग्री सेंटीग्रेडच्या करस्पॉन्डिंगची HFG ची व्हॅल्यू किती येते 2465.9 2465.9. That value is in kilojoule per kg. Are you getting? So from steam table, I will get the value of HFG for 15 degree centigrade. Is there? Nikhil Munde. So from steam table, I will get the value of HFG of DP, that is nothing but 2466.1 kilojoule per kg. Put that value of HFG of DP. So rest of all the things you are knowing. H is equal to 1.022. Then formula is H is equal to H is equal to 1.022 TD. TD किती 30 degree centigrade plus small w, that should be in terms of kg per kg of dry air. Inside the bracket HFG of DP plus 2.3 TDP. So here I will get the value of H. Are you getting? So here initially we were knowing only two values, dry bulb temperature and wet bulb temperature. And based on that two values only, we have calculated remaining all the values of that atmospheric air. Are you getting how to calculate remaining all the values of that atmospheric air? So here we have completed the problem. Have you understood how to solve the problem? Yes or no? Write in the chat box. Have you understood? Is there any query, any question? If you are facing any query or any question, you can ask me. I will give 1 or 2 minute time. Otherwise, if you have understood, write yes in the chat box. What about remaining student? Have you understood? Please write yes or no. Only 2 or 3 students are writing. What about remaining student? Okay, so we'll take next problem. Likewise, if you understood first problem, you can solve remaining all the types of problem, because all the types or all the points we have covered in the single problem only. So similarly, I will take the another problem. So here I will proceed with fast speed. So for dry bulb temperature of 38 degrees centigrade, for dry bulb temperature of 38 degrees centigrade and a relative humidity of 70%, calculate the following for year if barometric pressure is 1 bar. Barometric pressure दिलेला आहे किती 1 bar. So what quantities we have to find out? First of all, I have to find out the specific humidity, small w, enthalpy of the air H, TDP, and partial pressure of dry air. Out of that, how to calculate here? कोणत्या दोन क्वांटिटी दिले? फर्स्ट वन ड्राय बल्ब टेम्परेचर दिले. ड्राय बल्ब टेम्परेचरच्या करस्पॉन्डिंगचं प्रेशर, ड्राय बल्ब टेम्परेचरच्या करस्पॉन्डिंगचं प्रेशर म्हणजे काय माहिती आहे मला? पीएस माहित आहे. रिलेटिव्ह ह्युमिडिटी दिलेली आहे. रिलेटिव्ह ह्युमिडिटी म्हणजे काय असतं? पीव्ही बाय पीएस असतं. इथं बघा, मला काय माहित आहे? ड्राय बल्ब टेम्परेचर माहित आहे. ड्राय बल्ब टेम्परेचर माहित आहे 38 डिग्री सेंटीग्रेड. त्याच्या करस्पॉन्डिंगचं मला काय कॅल्क्युलेट करता येईल? पीएस कॅल्क्युलेट करता येईल. पीएस कॅल्क्युलेट करता येईल. परत रिलेटिव्ह ह्युमिडिटी दिली 70%. रिलेटिव्ह ह्युमिडिटी म्हणजे काय असतं? पीव्ही बाय पीएस असतं. पीव्ही बाय पीएस. तर ह्या ठिकाणी रिलेटिव्ह ह्युमिडिटी माहित आहे, पीएस माहित आहे. त्यावरून काय कॅल्क्युलेट करता येईल मला? पीव्ही कॅल्क्युलेट करता येईल. पीव्ही कॅल्क्युलेट करता येईल. एकदा पीव्ही कॅल्क्युलेट केला का परत मला काय कॅल्क्युलेट करता येईल? ड्यू पॉइंट टेम्परेचर कॅल्क्युलेट करता येईल. टीडीपी कॅल्क्युलेट करता येईल. आणि एकदा पीव्ही कॅल्क्युलेट केला की परत बाकीच्या सगळ्या गोष्टी कॅल्क्युलेट करता येतात. स्मॉल डब्ल्यू काय असणार आहे? 0.622 पीव्ही डिवाइडेड बाय पी मायनस पीव्ही. लाईकवाइज स्मॉल डब्ल्यू कॅल्क्युलेट करता येईल, एच कॅल्क्युलेट करता येईल, पार्शियल प्रेशर ऑफ वॉटर वेपर कॅल्क्युलेट, सॉरी पार्शियल प्रेशर ऑफ ड्राय एअर कॅल्क्युलेट करता येईल. सो लाईकवाइज वी हॅव टू प्रोसीड फर्दर. So here, as dry bulb temperature given, relative humidity given, and barometric pressure is given. So first of all, to calculate the value of specific humidity, formula is small w is equal to 0.622 pv divided by pb minus pv. पण pv माहित नाही आपल्याला. या ठिकाणी pv काय आहे? unknown quantity. So to calculate the value of pv, we'll take the help of steam table. And first of all, with the help of dry bulb temperature, I will calculate the value of ps. And after getting the value of PS, I'll put that value of PS in the formula of phi. Phi is nothing but PV by PS. PV by PS. So here I'll automatically get the value of PV. So here, as phi is equal to PV by PS, which is equal to 0.7. So PV by PS is equal to 0.7. And as dry bulb temperature is 38 degrees centigrade. Dry bulb temperature is 38 degrees centigrade. So corresponding pressure 38 degree centigrade च्या corresponding pressure directly from steam table बघायचं तुम्हाला. आता ह्या ठिकाणी कॅल्क्युलेशन कशासाठी केले दाखवतो तुम्हाला. हे जे कॅल्क्युलेशन आहे, कारण की काय काही स्टीम टेबल मध्ये ती जी व्हॅल्यू दिलेली असते ती कशामध्ये दिलेली असते? एमएम ऑफ एचजी मध्ये दिलेली असते. स्टीम टेबल जर बघितले तर काय स्टीम टेबल मध्ये ती व्हॅल्यू, प्रेशरची व्हॅल्यू एमएम ऑफ एचजी मध्ये दिलेली असते. काही स्टीम टेबल मध्ये ती न्यूटन पर मीटर स्क्वेअर मध्ये दिलेली असते आणि काही स्टीम टेबल मध्ये ती बार मध्ये दिलेली असते. आता ह्या ठिकाणी आपल्याकडे जो स्टीम टेबल आहे त्या स्टीम टेबल मध्ये आपली व्हॅल्यू जी दिलेली आहे, आपल्याकडे असणाऱ्या स्टीम टेबल मध्ये जी काही व्हॅल्यू दिलेली आहे ती कशामध्ये दिलेली आहे? बार मध्ये दिलेली. त्यामुळे डायरेक्टली ती व्हॅल्यू घ्यायची 38 डिग्री सेंटीग्रेडच्या करस्पॉन्डिंगची व्हॅल्यू. 38 डिग्री सेंटीग्रेड ही 38 डिग्री आणि त्या करस्पॉन्डिंगची प्रेशरची व्हॅल्यू किती येते? 0.0666 सॉरी 0.0663. 0.0663. सो 0.066 या ठिकाणी 236 आहे. 3 डिजिट नंतर थोडीफार चेंज झाली तरी काय प्रॉब्लेम नाही. या ठिकाणी चेंज कशामुळे झालेले? कारण की आपण स्टीम टेबल मध्ये जी काही व्हॅल्यू होती ती एमएम ऑफ एचजी मध्ये होती, त्याचं कन्वर्जन मी बार मध्ये केले. पण आता जो स्टीम टेबल आहे त्याचे त्यात डायरेक्टली कशामध्ये मिळते? बार मध्ये मिळते. सो हियर आय एम गेटिंग द व्हॅल्यू ऑफ पीएस. पुट दॅट व्हॅल्यू ऑफ पीएस हियर. आय विल ऑटोमॅटिकली गेट द व्हॅल्यू ऑफ पीव्ही. So here I will get the value of PV. आता व्हॅल्यू ऑफ पीव्ही मिळाल्यानंतर त्याच्या करस्पॉन्डिंगचं जे काय टेम्परेचर असणार आहे 0.04636 बार, त्याच्या करस्पॉन्डिंगचं जे काय टेम्परेचर असणार आहे ते म्हणजे काय असणार आहे, ड्यू पॉइंट टेम्परेचर असणार आहे. ते ड्यू पॉइंट टेम्परेचर नंतर फाइंड आउट करता येईल, पण पीव्हीच्या साह्यानं आता मी काय कॅल्क्युलेट करू शकतोय, स्मॉल डब्ल्यू कॅल्क्युलेट करू शकतोय. स्पेसिफिक ह्युमिडिटी फर्स्ट पॉइंट 0.622 PV divided by PB minus PV. So put the value of PV, I will get the value of small w. That should be in terms of kg per kg of dry air. After small w, I have to calculate the value of H. H is equal to 1.022 TD small w HF job dP plus 2.3 TDP. आता ह्या ठिकाणी ड्यू पॉइंट टेम्परेचर लागते. ड्यू पॉइंट टेम्परेचर साठी मी काय करणार आहे, ही जी काय पीव्ही ची व्हॅल्यू आहे त्याच्या करस्पॉन्डिंगचं टेम्परेचर फाइंड आउट करणार आहे स्टीम टेबल मध्ये 0.04636 0.04636. आता मी काय करणार 0.04636 0.046 काय होती व्हॅल्यू आपली 0.046 पीव्ही ची व्हॅल्यू काय आहे, ओके 0.04636 आहे. आता बघा 0.046 कुठे येते, 0.0424547. ओके ह्या ठिकाणी 0.04636 आहे. तर ह्या ठिकाणी 31 डिग्री सेंटीग्रेड साठी किती आहे 0.0450 आहे आणि 32 साठी 0.0476 आहे. या ठिकाणी जर तुम्ही इंटरपोलेशनचा फॉर्म्युला यूज केला तर इंटरपोलेशनच्या सहाय्याने तुम्हाला काय मिळेल, या ठिकाणी व्हॅल्यू ऑफ ड्यू पॉइंट टेम्परेचर मिळेल आणि ती कोणती येणार आहे, इन बिटवीन 31 आणि 32 येणार आहे. पण आपली व्हॅल्यू आहे 0.04636 आणि ह्या दोन्ही व्हॅल्यू जर बघितलं तर ती 31.5 किंवा 31.6 डिग्री सेंटीग्रेडला येईल आणि त्याच्या करस्पॉन्डिंगची HFG, त्याच्या करस्पॉन्डिंगची HFG आता 31.5 जर आलं तर काय करणार, 31 ची HFG घेणार, 32 ची HFG घेणार आणि त्या दोन्हीचा अवरेज करणार. ती म्हणजे काय असणार आहे, म्हणजे 31.5 डिग्री सेंटीग्रेडची HFG असणार. सो लाईकवाइज, सो हियर by using interpolation you can calculate the value of dew point temperature. So here if you find out the value that value of dew point temperature is 31.5 degree centigrade and corresponding TDP HFG value is nothing but 2426 kilojoule per kg. या ठिकाणी 31.5 आल्यामुळे डायरेक्टली तुम्ही काय करणार आहे, एव्हरेज आउट करणार. 31 चा HFG घेणार, 32 चा HFG घेणार, दोन्हीची ऍडिशन करणार, डिवाइडेड बाय 2 करणार. दॅट इज नथिंग बट HFG फॉर 31.5 डिग्री सेंटीग्रेड. So here I will get the value of H also. That value of H will be in terms of kilojoule per kg of dry air. After getting that, I have to find out the value of dew point temperature. Already I have calculated the value of dew point temperature. And lastly, I have to find out the value of partial pressure of dry air. आता ह्या ठिकाणी barometric pressure माहित आहे. Barometric pressure is nothing but it is the summation of PA plus PV. त्यापैकी barometric pressure ची व्हॅल्यू माहित आहे मला, PV ची व्हॅल्यू माहित आहे मला. कशाची व्हॅल्यू कॅल्क्युलेट करायची, पार्शियल प्रेशर ऑफ ड्राय एअर ची व्हॅल्यू कॅल्क्युलेट करायची. तर PB ची व्हॅल्यू पुटअप करा, PV ची व्हॅल्यू पुटअप करा, या ठिकाणी मला काय मिळेल, PA ची व्हॅल्यू मिळेल. सो दिस इज द व्हॅल्यू ऑफ PA. So likewise we have covered the numericals based on psychometric relations also. Numericals based on psychometric relations. Are you getting? Yes or no? Have you got the point how to calculate the numericals based on psychometric relations? Yes or no?
Yes, sir.
So we have to stop our lecture here. So before stopping the lecture, I have to take the attendance. Wait for 1 minute.